Because if we are saying we want to replicate the human intelligence, we'll never do it. I mean, not in the next 50 or 100 years.
Hi everyone, and thank you for coming for this second edition of this podcast called I Scientist. My guest today is Jonas Gonzalez, who is a young researcher in my team who finished his PhD in 2020 at the University of Genoa, Italy, on AI and robotics, right?
Yes.
But of course, it was 2020, the year of COVID, so it didn't go as planned. And I really liked the way Jonas bootstrapped himself out of this problem, and I will hope to hear more about that. We will cover some topics on robotics, AI, why robotics is important for AI, and how AI will help robotics. So maybe, Jonas, tell us who you are, where you're coming from, why you chose this interesting domain, and how did you end up doing a PhD?
Okay. So, hi everybody. Thank you, Balash, for inviting me for this podcast. I'm really excited to talk about our research together and the future of AI and robotics. So, my name is Jonas. I'm a Franco-Colombian. I was born in Colombia but raised in France. I would say that I've always been passionate about science and understanding the world around us. So during my teenage, I was fascinated by mathematics, physics, and actually, for the little story, at the beginning of my university, I wanted to be a theoretical physicist and work on quantum physics. So at the university in France, how it works in the first year, you are kind of generalist. So I had mathematics, physics, and computer science. And beforehand, I had no idea about computer. I was using them for internet and video games. And that was the first time I discovered coding and programming. And I have to say it, I've been a fan of it directly. From the first code that I wrote, I remember was in Java. And I really like the fact that you could program something to do something concrete on your computer. So for me, it was game changing. And so I switched my plan, and I decided to follow on this domain. And I had the chance to add an interdisciplinary course on artificial intelligence. And for me, that was the revelation, because it was the mix between computer science and mathematics and the field of AI that was growing at this age. And so here start my journey into the AI and robotic fields. So I've been studying more AI and computer science, both together. So keeping always a mathematical background. So not theoretical, but the one that you need to do AI. So linear algebra, calculus, all of this. And when I came to my PhD choice, I wanted to explore the application into robotics, because for me, robotics is the perfect platform to do AI. Because the main goal of AI at the end is to reproduce the human intelligence. And for me, human intelligence, you cannot dissociate it with the body. And that's why robots are the perfect platform. So I start my PhD, as you said, at the University of Geneva on robotics on AI. And I did my 3 years, so working on how the tool could be used to make autonomous agent that can learn and interact with us naturally. And after this, I had the chance to come to work with you at Huawei. That was driven because I wanted to get more theoretical knowledge about machine learning, and also to develop my knowledge in mathematics. And so far, I've been a success. I was very thrilled to work with you, with the other colleagues that are wonderful. I learn a lot, and I think also I bring also my point of view of AI. and but I'm really excited about this field as we'll discuss today.
Okay, great. And we have a lot of interesting lunch conversations, which is why I invited you, because I think the listeners would be also interested in those things. So when you said something that occurred me, like something that's not really what most of the people in the field think, which is that AI or intelligence is not separable from the body. So tell us more about this, because it's not something that most of the AI researchers think. I think most of us think that it's the body is just supporting the mind, and the mind is where the intelligence is.
Yes, exactly. So in cognitive science, especially, you have this research area which is called embodied AI. And the philosophical stance is to say that intelligence, the human intelligence as we define them, cannot be separated from the body. Why? Because you have a continuous communication between the body and the mind. And recent discovery in neuroscience tend to confirm this fact. We can think about the neural system that we have in our guts that communicate continuously to the brain, which means we kind of crude way to say that two brains, but meaning that you have way more communication between our body and the mind as we represent it. And in the history of AI, there were always this division where people thought that you can represent AI with abstract symbol or through mathematics and only resume it to it. And whereas this embodied AI researcher thought that you need actually to have a body to develop along with the mind. So that's the main stance of this philosophy.
Uh-huh. So what do you think is then all this recent news about like GPT or language models which don't have a body, and people are afraid of them already? There is a lot of fear that if we put AI into things that can act in the world, it's more dangerous than just an AI that's sitting there on the computer and talks to us. And there is another school, I think, which we are a member of, which thinks that we should put AI into agents, because this is how it will be aligned to the world that we live in, right?
Yes.
So what do you think about this?
I think ChatGPT and GPT, so the foundation model behind it, right now is making a lot of noise because I think for the first time we have a technology that is mature enough to actually produce something useful for the society. And when I said society, is more about company. You can actually build from it and it works. And this actually is one of the game changer, especially in NLP, because before it was a lot of specialization. So you had the machine learning engineer that had to understand well the problem and he will design a solution for this specific task. Right now, the paradigm changed because we have this foundation model that is generalist, and with few very good data sets, you can actually fine tune them to do a specific task. And I think the hype around that is this because it has very powerful application. But the problem with the media right now is that they don't explain well all the theory behind what is all the construct, the human knowledge that has been injected in those technology and those tools. For me, those are tools. And that's what scary people because they don't really understand what is behind, for my opinion.
Uh-huh. And so let's try to imagine the world where we put GPT-3 in robots or in appliances, so you can maybe converse with your Wi-Fi at home to make sure that your connection is getting better, or you can converse with your oven, tell it when to stop eating. So what will be different? Like how will we live this from our perspective? What do you think?
I think already putting ChatGPT into a robot, there is a lot of challenge that we need to face, which right now the big tech company are getting into it, which is multimodality. Because when you are talking about robots, you have different sensor information. So you have, for example, cameras, audio, which audio can be then translated to text and then can be used for ChatGPT. But if we are talking just putting ChatGPT inside the robot, it's just a new interface, which the robot with embodiment will produce some nice effect on socialization with the people. But at the end, behind the technology will be as before. It will not. You just change the mean of the interface to communicate with. But on the other scale, the one that where they are trying to build this multimodal foundation model, yeah, I think it's very exciting in a sense. And my analogy for me is a little bit like our DNA. When we are baby, we don't come to life with an empty system. We have those foundation models, which has been developed and learned during evolutionary process. So in our brain, for example, the cerebellum is shared with very primitive species, and the human brain built on top of it to develop more and more complex cognitive ability. And I think right now this foundation model can be seen as this, just as the starting system. But then, as you said, with robots, what is nice, because they're embodied in the world, they can actually interact with us physically and naturally. You can then teach him like a children. A children, when you come to a baby, when you come to the world, it's up to the society to align him to the society. How do you say, the society reference and the society code, the cultural code of the society where you evolve. And we are also seeing this right now with different culture. For example, if you are raised, I can talk about my personal experience between the Colombian culture and the French culture, European culture. You have a huge gap. The mentality are completely different. And that's because during when I talk with my cousin, because they live in Colombia, not in France. They have different social code that they need to follow, and that will build our personality, the fact that I am. But this will depend on external context. And for me, it will be the same for the robot. You can teach the robot to be really bad, but the important thing will depend on the other people that will teach the robot.
So what I find super interesting in this is that right now, and it's not very well known perhaps, that right now GPT-4 is one block of software. So everybody who talks to GPT-4 talks to the same software, same tool. It doesn't have memory. It has short-term memory, so when you give it a prompt, it can remember the prompt, and this is why it's so powerful, because that memory is pretty long. So you can prompt it in a pretty sophisticated way. But when you come back tomorrow, it will forget about your conversation. And this is because it's one big software that's running on a server. Whereas if you put it in a robot or anything that has its own existence in time, it will, I mean, we have to solve some algorithmic problems there, because we don't know exactly how to do this, but that's not so, it's actually not such a complex question as what we had to solve to get to the GPT-4 level. But once we solve those things, it will be able to absorb experience, learn for itself, which means that the software, the AI, or the thing together, if you want, embodied AI, it will have its own individual, you can say, personality, right?
Yes.
And that means a lot of things that we take for granted as humans, like you have a different set of experience, different genes also, but different set of experiences that, as you said, your cousins who grew up in Colombia have a different behavior because they learned a different culture. So when this will happen, it will mean that it's not going to be one GPT-4. It will be as many GPT-4s as robots that have that capacity to speak. But their experience will all be different. And there are a lot of consequences. I don't know, what do you think about this? Because I have some ideas, but let's
you're totally right. So each robot will develop its own experience, so it's on data set, if we can talk like this, because at the end, those are machines that we are building, so we have the full control of it. And maybe people also, the fear that people have right now against GPT models, foundation models, I think also, as you said before, is they don't understand that at the end, those are tools, software tools. I mean, a very shocking example was when you are using ChatGPT, the model itself, as you said, can only process a prompt at a time. So how you manage to get to remember the context of the conversation? Where actually what they do is they just re-inject all the conversation you had so far into the model, into the prompt. And this is something that you have in the backend running, but meaning that without this, and this is pure coding programming, without this, the model is not able to be a chatbot. And so people doesn't understand this. The model is not able to do a real conversation. You need to have another technological stack, because it's a tool to actually make it seem that is a chatbot. But behind the scene, there is a lot of human engineering. And that's what people, I think, miss, and the media don't advertise much. And so coming back for the robot, for me, that's exactly there is very, I think, difficult challenge to solve. And one, as you said, is the fact that as soon as you put GPT into a robot, you will per se give him dynamicity, in the sense that it will last in time, as you said. That means he can collect, act, in a word, collect data, be actor of where to collect the data. But also what we are doing right now is we are learning a deep neural network, but then we freeze them. That means that we only have point estimate of the weight of our neural network. And right now, the field of continual learning, which is how we can update those weight and avoid the effect of catastrophic forgetting, which is when I learn a task A, I'm learning the task B without unlearning the task A. This is something that is not solved at all. Right now, the best technique that exists is to actually retrain a model from scratch, from the data from task A and from task B. And this is a challenge that for me is far to be solved. And the merging of the AI community with robotic will have to face this to actually develop then a self and everything that comes to it. But without this, we will just collect more data, increasing the data set, retrain, do a point estimate of our model, and deploy it into the robot. But this is just a technological trick. It's a software trick. What we really want is like the human. If we think of our brain, is always evolving, always learning. Every night when we go to sleep, you have new connection that form, you have connection that delete because of the experience you have of your day. It will reorganize itself always. And this, we don't have it with artificial neural network.
I see. And another thing that comes in mind is when you start having experience, you remember that experience, and that's a different type of memory than the, let's say, memory that GPT-4 has, which more or less we can call it semantic memory. Same
Yes.
terminology as in cognitive science. But when you start to have experience, you develop what we call episodic memory, which is the memory of events that happened to you. And it's a memory that it's hard to externalize because it's actually happened to your body. So it's the actual memory of your sensations that you had when that thing happened. And so I'm wondering what you think about this, because then you know, I don't think we have any technology to do that. But one of the main problem why we don't have it is that we will equip the robot with sensors. It will have vision, like a camera, maybe audio, touch, and there will be a lot of sensors. Like there are a lot of pixels in the camera, if you just want to talk about computer vision. But in our bodies, we have a lot of neurons that are transmitting information from the outside world to the inside. And one of the things we can do very efficiently and very rapidly, because we have to, is to filter this information, right? And this is a very tough task because it's hard to learn. It has to before you start learning facts, things have to be filtered. And this filtering is a very low level thing that happens very early in let's say, the information chain, the information that comes from the outside and gets into your sensors and then gets into your cognition. And I don't think a lot of people are actually thinking about how to do this. So, but this is for me one of the obstacles of why this will be hard to put AI into robots, because somehow we have to solve this thing. The robot will have to know what's relevant in any situation to actually sense, you know?
Yes, I agree with you. So you have the bottom up process where you take the raw information from the sensory system. So we can take the example of the human eyes, but also in neuroscience, what they discover, you have a lot of top down process, which means that you have priors that you learn in your brain that you can re-inject into the sensory system. And one example of that is optical illusion. Optical illusion, from the bottom up process, you are sensing all the information that you need. But at the higher level, for me, what you're saying about the filter, for me, I see it as the representation that you learn in deep learning. It's a latent representation that is generic enough to then to have nice property. A little bit like, for me, GPT, the foundation model. They learn really good representation of the language that can then be used to perform different tasks based on the language. And for me, in the human brain, is the same. Then after, when you have those representations, they can influence your perception. And that's really strong, meaning that you have an internal model that you project to the outside. And this is what also the robot would have to do. And I think also that's why I really like the axis of research of model-based reinforcement learning, because there is the idea where the agent, based on his experience, on his action, will build an internal model, an internal representation of the outside world that is going to be unique, because this agent, as we said, will experience different data, will also act differently from one agent to another one. Certainly, we'll have a very unique system model in his mind. And then also, what I think is important is to make them communicate to the other. And that's what also is, according to me, one aspect of the human intelligence, which it's called cultural learning, where actually our intelligence is also, because it's built by interacting with each other. And like this, the internet model can kind of align to the same representation, and then we can build and talk about the world also that we are leading together. Because we all have, at the end, even if we have different experiences, we have common representation that we can share and talk about it to express and explain the world around us.
Yeah, we bind to each other, and we bind to realities through the sensors. And I agree with you very much. I think the number is 80%. So 80% of your perception is top down. 80% of what you see is coming from inside, and only 20% comes in the other direction, that updates or maybe it changes what you see. And it can actually go wrong. So this is one of my pet theories, that a lot of people think that intelligence in itself is something that evolution selects for.
Yes.
So it selects, evolution goes always in the direction of more and more intelligent beings. And it's, of course, there is one effect that goes against it, which is energy consumptions. Like our brain consumes like 20 to 25% of the energy that our body consumes. So it's very, very energy hungry. We need to eat a lot, and so we need the intelligence to find the food. And so evolution had to bootstrap out of this loop. But there might be another thing, which is when we start to build internal models, there's a tendency of doing the projection too much. And so you can build your internal model of the world, and then instead of living in the world and looking at outside, you just start projecting your internal world onto the external world. And you basically become schizophrenic. So schizophrenia is this mental illness where everything is about your internal model, and you don't have this machinery of trying to balance between what's coming inside and what's going from outside. You need the machinery of projection, because this is where your knowledge is, whether you learn it or you were born with, which help you to navigate in the world. You couldn't live without an internal model. So every animal has it, but I think the more intelligent we have, the bigger this model is, and the bigger the role of this model in perceiving the world, to the extent where it can go wrong in the other way. So I have this pet theory that intelligence might have a limit where it just cannot handle itself, its own smartness. You see what I mean? Like
Yes.
it becomes too smart, it becomes too much holding to its map, because basically this model, you can visualize it as a map that you construct about the world. And when the world becomes the map, it's as bad as when you don't have a map at all.
Yes.
So it's not something where intelligence is like, the more intelligent you are, the more chance you have to survive. Maybe there is like a not necessarily physical, like energetic limit, but this kind of internal limit of intelligence. So and if it's true, then I'm not sure that AGI can happen, right? So that there's no, I know I have no proof whatsoever about this limit, but this can be the case. So what do you think about this?
That AGI cannot happen because, if I understood well the question, because there is some limits in the
Yeah.
internal
So
model that you
yeah.
have.
So let me maybe make it more precise. So when I say AGI, it's not it's not that something more intelligent than human, but an intelligence that can improve its intelligence indefinitely. Maybe there's a limit,
Okay.
especially so this is very much bound to your proposal of embodiment, because if we don't embody it, it doesn't have any stakes in misperceiving the world, like GPT-4 confabulates a lot if it's not reined in with reinforcement learning with human feedback. It makes up a lot of things. It doesn't matter, but once you have a body and your survival depends on limiting your confabulation, let's say, or if you act on your confabulation and you hurt yourself, you may die, then of course that will be one way to sort of align the robots, right? Because it will have to stop confabulating too much. We confabulate too, so it's not like we don't do anything of that sort, but there is a limit, and we are also always facing reality. So once you put it in a body, then this idea that I have may happen, that if it gets too intelligent, if its internal model takes over, it will die, because it will not be able to adapt to situations that it has never seen. It will just always project the model out. See what I mean?
Yes, exactly. Yes. So going back to what we said before, I think that's where the dynamic learning, the continual learning aspect is really important, because this is exactly what we humans do. And also, I think one of the particularity of human intelligence is having the ability also to question our own internal model, which is what we call the consciousness, which is I am, and I can actually question my internal model, saying, am I right? Or can I update my belief? And for this, I will go back also with the importance of the society, of the culture, because it's going to be the other that are going to, with communication, with interacting, that are going to challenge your internal model. And this is what is happening. For me, I'm seeing the brain as a little scientist, and he's doing each time experiment on the world around him. And his goal is to develop the internal model that, as you said, a bit maybe linked with the energy consumption, which will optimize the energy consumption of the machinery, and also, and to be coherent with the reality. And each time our brain can do a sample experiment to see what is going on, and it can adapt itself always. I'm trying to visualize like this. We have a little scientist that is doing everyday experiment, and every night he collect the data, and he can update his internal model. And to finish about AGI, in my PhD, so I was doing cognitive developmental robotics. So the goal is to try to replicate the learning path of the human into the robots. So as I said before, the idea is not, you cannot go and program a 15 or 20 years old intelligence, but rather you should giving all the tool, the architecture, the cognitive architecture at the start, and then let him learn by himself, by interacting with people, by collecting data with the world. It's like you are equipping your little scientist with all the tools he needs to perform experiments. And this, for example, is something that I see in research right now that we don't have, which is the continual learning aspect. We don't have this because right now we are good to learn for a specific task, but we don't know how to make evolve those models.
I have a question on this because, okay, so it's a little scientist. So let's talk about science, like the scientific method. Somehow, since Popper 30s, you know, the falsifiability, so the scientific method means that you can only say things that you can imaginally falsify in an experiment. So if there is no imagined experiment that can falsify it, then it's not science, right? Yeah. And so the method that followed from this is a very pure method, is that you have an idea, a hypothesis about the world, how the world works, and you design an experiment which if it falsifies it, so it tells that your idea was wrong, you just discard it. If it doesn't, then you can add this idea to the set of things, propositions or statements that that you think are true. Okay, you can never prove that something is true, but you can prove that something is false. This is beautiful, right? This is how all science works since at least a century, even before, but since Popper, it's formalized in this way. There's one problem with this, and it relates to your little scientist in the robot, is where do these hypotheses come from, right?
Okay.
Who decides what experiment to do?
Okay.
It's sort of like an orthogonal question, a different question from truth. It's about the value of the proposition. Yes. The meaning. Why are you interested in this? And as a scientist, I started to be interested in this question of why did I work on the Higgs boson? Right? I'm an AI scientist, but I worked with physicists, and it was a lot of fun to work with them. So that's one answer. But I wanted to dig deeper, you know? Why at all a group of people work on the Higgs boson, right? John Vervaeke has this beautiful stack, if you want, this computer science terminology, stack of knowing, 4P, where you have propositions. Propositional knowing is what is true, what is false. Procedural knowing, where you know how to act. And by acting, you can achieve a value. So that's typically what we do in robotics or reinforcement learning. We formalize this and we do it. We learn how to act to achieve a good value, but it still doesn't tell you where the value comes from, right? And that's sort of the same question. And so Vervaeke's answer to that is that it comes from embodied cognition. You will be interested in knowing things that help you to survive If something
Yes.
hurts you, that's bad, but it's also important to know it, right? If it's something that you are neutral to, it doesn't give you food, it doesn't give you any new information, it doesn't help you to live, you can ignore it. And this is what you remember I mentioned, that this thing that we try to model the filtering, that filtering depends on that level. And it's a deeply internal kind of knowing. He calls it perspectival. This is where what he calls relevance realization happens. When you walk in the room, you take a sort of an identity. Let's say now I'm a podcast host, but I can also work in a classroom and I'm a teacher, or I walk in my office and I'm the head of the team. Those are different identities I can take, and the room around me takes another identity he calls arena. And so I have this agent-arena relationship that manifests itself while you're doing things, right? So he says that the value that you will then learn how to achieve with the procedural knowing comes from this level. Things become valuable to you because you have a body and you act or you live in a certain reality. And so the glass becomes relevant because I can drink and I'm thirsty, right? So the funny things about the Higgs boson is the following. I cannot really say how it's related to my embodied existence. It still doesn't explain why we work on the Higgs boson.
You
right?
can actually.
Okay,
I mean, you can.
because this is like my quest, This is my
And you
question.
can.
Why did I work on the Higgs boson?
You can explain it by what I said before about the cultural learning.
Okay.
Because our society evolved always to favor the understanding of the world. Why? Because at some point of the history, we understood that understanding the world around us with mathematics, but also with tools, allow us to develop a wider range of action on the world. And that's what we are doing with AI. AI, we are just building new tools to try to understand ourselves at the end. That's what we are doing.
I agree.
And this is something that I don't think there is right now a clear answer about that. Is when you see the big apes, they have wonderful ability of adaptation. They can learn sign language, but they don't have this internal drive to always go beyond, to always try to understand more about the world around us. And I can give you an
I
example.
might disagree of this, but yeah, just skip your thought. But if you think about dogs, they go behind every tree to see what's there. So I think this exploration behavior is also in animals, maybe not as
but it's more short term.
Yeah,
it's more
that's
like
true. That's true.
It's short term.
Yeah.
That the real, and I think the real thing that we will never manage, or at least is really difficult to replicate, is this cultural knowledge, intelligence that we have as a society. Is like if it's a bit like the emergence from all our history. Every humans, we emerge some common knowledge that we are following. Like we pursue research because we know that if you understand the world more, you can act on it, you can prevent some events, and that goes for the Higgs boson. I mean, Einstein allow us to again explore the space, give us the GPS. Quantum physics give us the mathematics to do miniature cards, so transistor to do the computer. So everything is linked to the growing of the humanity knowledge.
I agree. But still, it's maybe just me, but when I look at Verwecke's 4P, I expected to explain the value of the knowledge of the mass of the Higgs boson. Let's say it's 125 JeV, which is, to to be important for my own existence. And there is just no way, you know, when my partner asks me about why am I doing that, I don't have an answer. I can say what you say, but it's still not related to me personally. So I've been thinking about this, and the thing where it leads to, at least in my mind, is higher level collective consciousness. And it's a little bit what you are getting at, like how these things, these meanings, because basically it's what I mean by value is that it's meaningful for something to know that the mass of the Higgs boson is 125 GeV. It is meaningful for some being, for the actual existence of some being. For example, it is meaningful for the collaboration of those 10,000 physicists who built the Atlas detector and the LHC accelerator. But that being is not a human. It's a collective. And the reason why it could be very interesting in these current discussions on AGI is because it's a different kind of consciousness. And we already have a lot of experience with those consciousnesses, like family, couple, you know, in this sense, the couple is not just the sum of the two persons who form the couple, but it has its own consciousness that change the behavior of the individuals inside the group.
Yeah.
And so it's also an interesting way to poll the what this being is about, because the importance of the Higgs boson sort of emanated into the individual physicist, and it manifests itself as you said, it manifests itself as a human level value, connection, fun, doing fun together, looking at something that's we all look in the same direction. We have like a goal that's higher, that's bigger than us. We are part of the things that's bigger than us. So all this kind of what you can call religious feeling is basically the manifestation of this higher level goal at the human level. So it became like I was in another collaboration. We were studying cosmic rays, again, nothing to do with my life, you know. I stayed 8 years within that collaboration because I had so much fun with them. And the number of people was like 150 who were in it. It's exactly the Dunbar number. It's exactly this warm feeling of being in a human group that lives together and everybody knows everybody, and there is enough gossip to, you know, live because we live on gossip, you know, and all kind of things. But at the same time, we had this common goal, and it was binding us. And so this is what I got to, like, maybe the Higgs boson is not relevant for me, but it's relevant for this high order being. And the reason this might be interesting is because this is how we align ourselves to the society. That's what you were getting at too. Like we are connected to each other. We talk to each other. We communicate, and this group aligns us into itself, right? It's like a higher level body. So what I think about like alignment is exactly this. Like this is the way to go. We just have to be careful how we design the individual agent so it has stakes to survive. So stakes like responsibility for itself, but also responsibility to bind to reality and to us. And then the rest is just sort of nature, because this thing is like nature, you know. You cannot go against it, you know. Things bind to each other.
Yeah, it's true.
And of course,
I
you have
think
evil and everything, but still, the group that survives controls the evil.
yeah, it's true. No, I agree with you, and I think I would add also that I mean the Higgs boson for you was meaningful because as a society we identified that this area of research was really important for the advancement of the society. And that's the same for AI. Why people are doing research in AI and everything is because it's foreseen advancement that is going to grow the humanity, solve problems. But I think going back to the value, how the value come from, I think that this is the particularity of humans, because we have our primary value, which is our maintenance in the time, like eating, not dying, avoiding a risky situation. And what happened with human is like we managed to solve this by bounding as a society. So we develop farms, so people were not lacking food anymore. And this, when you solve those basic needs, what happened is like then you create new one, and that's for me the particularity of human. We always find new goals that will define the value then that we put to the thing. It's like right now we could stop. I mean, all the technological stance of the increasing of always increasing the economy, always increasing the money of the state. All of this is just construct of our society, but not interestingly the value of that. And right now we can see it is bad for the environment. You have a lot of inequality in our society, but nonetheless we are still keeping those value function, which right now, for example, would be to get money, to get a career. All of this is a construct of our society, and that's where then I think in the discussion of AGI, first we must identify what we want to build. Actually, for me, for example, what I want to build is a robot that is able to evolve in our society with us naturally, can learn new tasks, can adapt. But for now, I don't want him to be a human that creates his own goals and go that tense will be a person being. It's going to be a tool, a wonderful tool, but it's going to be a tool. And we are far away right now at the level of neuroscience, but also art science, mathematics, to mimic the fact that you can create your own goals, that you create this society knowledge. All of this, we are very far away of that. That's why when we talk about AGI, I think we need to put a goal. Because if we are saying we want to replicate the human intelligence, we'll never do it. I mean, not in the next 50 or 100 years. Because the tools that we are right now are so far away from the functioning of the human brain. I mean, when you see a deep neural network, as I said before, it's a point estimate of the weight, and then it's frozen in time. Whereas our brain is always updating its external model, so it's completely two different things. Then, can we approximate with these tools some aspect of the human intelligence? Yes. And for me, as I said before, the main challenge is to put what we have right now in AI, which I think is mature, to port it into robots, and to work on the dynamicity. So a bit like in reinforcement learning, you let the agent then interact with the environment, collect data, and you will see what happens. And I think we can replicate the level of intelligence of a dog, where you could have a robot that is aware of himself. He's not conscious our level, but he's conscious of his body. He knows that he has to avoid to fall, to not break. And he has the plasticity to learn new tasks from his affordance, from his capabilities. This is what dogs are doing. I mean, you can dress dog to guide blind people. You can dress dog to rescue in a catastrophe. And this is what we want right now, I think. But for me, it's really important to put the cursor of AGI, what we want. Because right now, also the discussion and all the fear of the society is because they really think that right now we are going to aim for human intelligence, and then from all the sci-fi culture about the books and the movie, they see that the robot will get conscious. He will realize that the human are the illness of the world, and he will try. For me, this is projection first of our own fear on a system that it doesn't work like us, so he will never reach this. because we start from two different bases first, and two, right now the technology that we have, we can actually go inside the robot brain, so the code, and we can change it if we don't like it. That's something that also people don't understand. It's not like something is uncontrollable. If it doesn't work as expected, you just shut it down. I mean, ChatGPT is
that's what
a
my neighbor
server.
said. Like, what's the big deal? You just turn it off.
Turn it off, because it will not have this this
Ah,
willingness of self-replicate in all the internet like you can see on some movies. And this is pure science fiction.
so let me steal on some of the counter arguments, because I mostly agree with you. I am perhaps more optimistic on the end, because I think if we start to put AI into bodies that are conscious about themselves, there is no theoretical reason why we couldn't get to human consciousness. But that's a long discussion, and there I definitely agree with you that it's very, very far. But the reason it's far, and I think we also agree on that, is because bodies are so hard to build. So it's so funny for me that all the science fictions of like 100 years ago or 50 years ago were about robots, and the robots were dumb, like, I don't know, Star Wars. But they already had their bodies and they were not falling, they could move. They were just stupid. It's exactly the opposite what happened. We had the language module of the robot, but we don't have the body. So
Yeah.
I mean, it took 15 years for Boston Dynamics to make a robot that can walk like humans, and that's kind of the speed with which this domain advances. And I remember you telling me that you worked with real robots and they break, and that's the big problem of doing robotics research, right?
Yes. The main problem is like you're working also with very expensive device. You need a team of engineer, because to fix a robot is not something that is easy. So you need to understand electronics, because it can be a cable that had just been unplugged. I mean, this is also what you need to realize when you build a robot is like electronic. So that means that if one cable just disconnected, the information doesn't flow anymore and the robot is useless. I mean, that's what people don't. I think people tend to overthink about the robot. They think about very complex technology, but they don't understand that it's the same technology that you have on your smartphone, on your computer, and they are not afraid about it. And it's exactly the same thing. And I agree with you that right now we could not explore the embodied AI. First, because I think the field of AI was not mature, because we have the winter of AI, where people thought that with expert system and rule-based programming, you could replicate all the human intelligence. They realized that will not do it. And then we had this winter until deep learning kick off, data-driven approach. And there we saw that you could actually do something. But what happened is like this research area got disconnected from the robotic research. Robotic research, I mean, when I was beginning my PhD, it was not uncommon to see hard-coded methods, for example, to detect object based on the color. So you change your color space to HSV because it's more robust to illumination. And then on the V value, you can actually isolate a range, which is the red. And so if you see a red ball, you can track only the red ball. But because it is a range, you kept also other steps. So a lot of engineering to do that. And that's what was the state of robotic 5-6 years ago. Then deep learning right now is mature enough because we have GPT, we have segment anything from Facebook, and also the computer vision field has been mature from several years now. And now they are ready to be put onto the robot. And as you said, also the challenge is to develop a platform that allow for errors, because we could not. That's something also that I think in AI we don't value much, is the fact that you can actually be wrong, and there's nothing wrong about it. It's nothing wrong to fall or to do something wrong, because you can actually learn a lot. you can learn a lot from your mistake. This is
Unless
the
you
main
break
point.
yourself.
Unless you break yourself. That's why first you need also to have a platform that is robust, that can fall like little children.
Yeah.
I mean,
There was this video about these two little robots playing soccer. The funniest thing was about the padding on them. They fell all the time, but they it was soft, so they got up.
yeah, and it's by falling also
Right.
that they can know that this is not something that I want.
Yeah.
But if you break and you break completely, then we can think about the existence of the robot. It's finished. So you break, that's it. So you don't know, you cannot learn how to recover from it. You cannot have introspection from it. So yeah, for me, this is one of the limitation, which right now you have a lot of company going into the development of humanoid robots. I mean, last week, I think 3 different startups advertise their humanoid robots. OpenAI is collaborating with a startup on humanoid robot to actually merge two. And I think right now is the moment of the merging. AI is mature enough. Robotics on the hardware and all the libraries to make a robot is mature enough also. And now we are ready to do the merging and to solve also the problem of doing the merging. Because then you have a lot of difficulties, challenges that you need to face for the robot. One, for example, when you see GPT was trained on trillion of data points, but is very diverse. But it's because they scrap all the web. You have a lot of all the information that the human
Exactly. Is what's relevant
right?
of this is doesn't know. Yeah.
But the robot, the problem is like when it will evolve into a very close environment with always the same thing. I mean, nobody change every day their furniture. So the challenge will be how you learn from very small sample size. And that's what I said before is my stance is like you can actually use the foundation model as a starting point and refine by the experience of the robot on his own experience, the foundation model.
Okay. So what's your dream, Jonas? Where do you want to be in 5, 10 years? What do you want to be known for?
My dream, actually, I realized that this year working with you, I think I have a mind that is pretty well suited for application engineering. So I think I'm very curious. So I read a lot. I like to learn new stuff. But then I think my strength will be to connect things. So I will not maybe do theoretical maths, invent a new algorithm. But I think my strength identified is to see the connection between several works, several research, and merge them together. And so right now, I'm really excited about my next step in research because I'm going to exactly do the merging that I was talking, where I have people, I'm going to work with people with you that you're expert more in AI without the robotic knowledge, because as I said before, there were 2 disconnected branches. And right now, what we can do is merge the 2 of them together, as I said, and experiment, do something actually on the real world. And so in 10 years, I will either follow in pure research, trying to achieve this goal, because I really believe that right now, AI is mature enough to be merged with robotics. You have a lot of challenges to face, but we will face them. And we will reach, maybe I'm over optimistic, but the human dog intelligence, for sure. I can foresee it in 10, 20 years, we'll have a dog intelligence.
So you will have like dog intelligence embodied into artificial dogs, huh?
Yes. Okay. It could be humanoids, but it will not be able to have all the very complex high-level intelligence of human, but he will be able to know that he need to maintain himself. He's aware of his body, he's aware about his environment, so he can navigate freely, he can plan tasks to accomplish something. And especially, he can learn new tasks easily based on his affordance and his capability, of course.
And we can communicate to it what the task would be.
Yeah, for me, that's one of the main requirements, that you need also to develop So this is the field of human-robot interaction, where you try also to understand all the social language, unconscious social language that we human use. Something that you are not aware because it's unconscious, but looking into the eyes, for example, when you are collaborating with someone, actually the gaze is a rich source of information to make two people collaborate efficiently. Because when you are inferring where the other is looking, you can infer in which object is going to be in the next step. So you can anticipate his action. So you can actually plan better to get the better plan. And I think this has also to take in account for the robot design.
Yeah, and dogs know this actually.
Yeah. And dogs are good
Dogs
on
know this,
this,
but not a lot of animals. Yeah.
on keeping those social cues. I mean, also
Yeah.
something stupid, but the voice. Dog know that when you raise the voice, something bad happen. Imagine for a robot, it's perfect. You can have a negative reward just by yelling at it. And that's how, for me, we are going also to do the alignment. If we have robots that can naturally interact with us, they are equipped with an architecture that allows them to learn in a continual way. We are the one that's going to align them. Every people will be responsible to align the robot to,
Yeah, like you do with your kids. You are
like you do with
responsible
your
for
kids.
them.
Yeah.
But again, let me just steelman the argument that makes people scary. It's I think what people are scary of is an agent like a robot. They are also even scared from software. But let's say a robot that can act in the world, and I can see the danger in this because it's physical. It can even inadvertently fall on you and kill you.
Yeah.
And it's intelligent enough to execute the value, the goal you give it,
Yeah.
and even plan steps towards that goal, but not intelligent enough to see that the sub goal it defined will just destroy you or destroy the world. So I think this is the dystopian argument. So what do you think about that?
I think it will depend also the goal that you will give to the robot. So you have also a little bit of morality that is embedded in each human. And as I see it right now, what could be done to actually constrain this is like maybe only the company that is developing the robot can actually align them. I mean, teach them, and once they are fully operational, you just release them without the possibility to update their knowledge. Just a software trick. You just disable the retraining of the model, and you give it as it is to the people. That will be a first, like say, security measure. But on the fear of all the people, I think depend on the AI research. I mean, I'm totally fan about the Yann Lequin point of view, and I think it has to do also with, as I said at the beginning of this video, the podcast, is we have a cultural knowledge, and Yann Lequin is French, and in France we have a huge history of philosophy, of we have the Enlightenment, and we have this kind of culture about where you need to think ahead, you need to understand deeply the stuff. We are really critics, and I think that make him the right people to talk about that, because he had this philosophical stance. He's an expert in his field, so he know the limitation, and he know that you will not bring the AI to destruction of the humans and everything, because we are the one that are programming it. We are completely at 100%. We can responsible about the development of the AI. We have full control. As we said before, if something goes bad, you just switch it off, restart the parameter, and going back. And it will have no memory for the AI will have no memory that you shut it down. Because we don't have this self-representation right now. We don't know what is consciousness in human. So how can we expect to have it in robots?
No, but I think it's the unconscious. It's I call it the high functioning zombie. Like zombie is this mythological figure, that mythology of modernity, let's say, this person who got rid of its personhood. It doesn't bind. The zombies don't bind to each other. They are just individuals. Their brain is eaten, but they still have like these low-level functions of surviving, eating, and they are not even evil because they are not moral agents, right?
Yeah.
And so my picture about this dystopian singularity argument is the high-functioning zombie, high-functioning in the sense that it's very capable of doing things, but it doesn't bind. It's not part of the society. It's somehow outside. I think the reason why we can fantasize about such thing is because of modernity, because the very reason why zombies are so popular is because they represent somehow the spirit of the time where we are like that, like we disconnect from the world. And so this is why, I think it's the way to align robots and AI is going to go through by aligning or realigning ourselves.
Yeah, totally. I totally agree with you about the fact that, and I think Europe is starting a journey in that sense where we will need to have a mondial consensus about this. What is the next step? Because then after it's technology, it's like the discovery of Einstein was used to make nuclear bomb. Well, it's the same for robots. You could use it to do soldier robots, but that will depend on our society, what we want as the next step for the humanity. But it's not the technology, is ourself. We as human that we have the control. It's not that we are letting the control to the robot and we cannot do anything. No, no, we have full control right now. And this is where I think philosophical stance, expert in AI need all to collaborate to reach a framework that is safe, aligned, and then we can build on it.
A roadmap, yeah. No, I very much agree. Okay, well, it's been more than an hour, I think. I forgot to put my
Yes.
clock, and it was a lot of fun. Thank you very much, Jonas.
I thank you to you for the podcast. I really love to talk with you. I mean, for a year and a half, we always have this discussion. I think it's really exciting time that we are living on.
Yeah, I agree. And I'm more excited than fearful. But that's probably our psychological setup. That's another big topic, but yeah.
Maybe also I'm a little bit naive because I'm young. I don't have so I'm optimistic, and maybe I will everything that I said about 10, 20 years, we're gonna eat a wall really, really quickly when the merging will happen between robotic and AI, and we'll have the next winter. That people don't understand. We could totally got there.
Yeah, well, okay. Thank you, Jonas, and I hope to continue the discussions with you, real life.
Yeah, okay. Of course. Thank you, Valas.
Thank you, Jonas. Bye.
Bye, bye.